Hello students, I hope you all are fine out there. So we are doing exercise 21A, isn't it? So in our previous video we have completed till question number 5. So today we'll start from question number 6. Okay, so let's begin. We have 1 minus tan A whole square plus 1 plus tan A whole square in the left hand side, and we are asked to prove this equals to 2 sec square A, isn't it? So let's begin. Let's copy the left hand side as it is. Left hand side equals to 1 minus tan A whole square plus 1 plus tan A whole square, isn't it? So we know the formula of A minus B whole square. Let us assume this one as A and tan A as B, okay? So A minus B whole square means, everybody knows this formula, isn't it? A minus B whole square means A square minus 2AB plus B square, isn't it? So we are going to apply this formula here. Let us assume this one as A and tan A as B, okay? A minus B whole square, which means A square, that means 1 square is 1 itself, so let us not write this square, okay? If I write 1 square, that means it will become 1, so 1 into 1 is 1, so let us not write this square. A minus B whole square equals to A square minus 2AB, isn't it? 2AB means 2 into 1, 2, A is 1, isn't it? 2AB. So this is 2AB. 2 into 1, 2. Tan A. B is tan A. Okay. So A square minus 2AB plus B square, that is tan square A, isn't it? So this plus comes here now. In the next expression we have 1 plus tan A whole square. So this is A plus B whole square. So what is the value of A plus B whole square? A square plus 2AB plus B square, isn't it? So let us put this formula here. A square means 1 square, that is 1, plus 2AB means 2 into 1 is 2 into B is tan A, isn't it? 2 tan A, 2AB plus B square is tan square A. Are you getting me? Okay, now let me erase this formula, we don't need now. So here we have minus 2 tan A and here we have plus 2 tan A. 2 tan A, 2 tan A. One is positive and another is negative. So let us cancel this out. So this plus 1 and this plus 1 gives us plus 2, isn't it? Plus 1 and plus 1 gives us plus 2. Plus tan square and plus tan square gives us plus 2 tan square A, isn't it? Plus tan square A plus tan square A gives us 2 tan square A. Now let us take 2 common from this, okay? 2 is taken common out, so what remains within the bracket? 1 plus tan square A, isn't it? So 2 ones are 2, plus into plus is plus, 2 into tan square A is 2 tan square A. This means, so we know that since sec square A minus tan square A equals to 1, this means sec square A equals to 1. Let us take this minus tan square A to the right hand side, it becomes plus tan square A, isn't it? So this was the formula which I gave you in the last video. So sec square A is 1 plus tan, sorry, this is square, okay? Tan square A becomes plus, minus tan square A becomes plus tan square A in the right hand side, isn't it? So sec square A is 1 plus tan square A. So this means instead of this 1 plus tan square A, I can write sec square A. 2, this means sec square A, isn't it? So this is the right hand side. We are asked to prove that. This means this is proved. Right hand side, isn't it? So proved. I hope you got this. Now let us move on to the next question, okay? Okay, now let us do question number 7. In the left hand side, we have cosec to the power 4a minus cosec square a. So we are asked to prove this equals to cot to the power 4a plus cot square a in the right hand side, isn't it? So let's begin. In the left hand side we have cosec to the power 4a minus cosec square a, isn't it? We have cosec to the power 4a minus cosec square a, and using this we are asked to prove this in the right hand side, isn't it? So let's begin. This cosec to the power 4a can be written as cosec square a whole square, isn't it? Since we know that a to the power 4 can be written as a square whole square. A to the power 4 can be written as a square whole square because 2 2s are 4, isn't it? Similarly, cosec to the power 4a can be written as cosec square whole square because 2 2s are 4, power becomes 4. And we have minus cosec square a, isn't it? So this minus cosec square a, we need cot in the right hand side, isn't it? So let's convert this into cot form, okay? Since we know that cosec square a minus cot square a equals to 1. Cosec square a minus cot square a equals to 1. This is the formula which I gave you yesterday, isn't it? So cosec square a equals to, let us take this minus cot square a to the right hand side, 1 plus cot square a, isn't it? This minus cot square a becomes 1 plus cot square a. So cosec square a can be written as 1 plus cot square a. Instead of this cosec square a, I am going to write 1 plus cot square a. Why am I converting this into cot square a form? Because I need cot in the right hand side, isn't it? So let's convert this also. This cosec square a also can be written as 1 plus cot square a. So this is cosec square a, so 1 plus cot square a, isn't it? 1 plus cot square a whole square. We have square here. Minus into plus, minus, minus into plus, minus, 1, minus into plus, minus cot square a. Are you getting me? I'm just multiplying with the minus sign, okay? Now we have, let us assume this one as a and cot square a as b, okay? This one is a and this is b. So a plus b whole square, we know the formula, isn't it? Everybody knows this. A plus b whole square equals to a square plus 2ab plus b square, isn't it? So this one is a and cot square a is b, okay? So a square means 1 square is 1, a square plus 2ab, 2 into 1, a is 1, 2 into 1 is 2, 2ab, b is cot square a, 2ab plus b square, isn't it? So b square is cot square a whole square, cot square a whole square. A square plus 2ab plus b square. So we have minus 1 minus cot square a. Now let us erase this, otherwise you will get confused with this, okay? Now this plus 1 and minus 1 can be cancelled, isn't it? Plus 1 and minus 1 becomes 0. So plus 2 cot square a. Okay, let's write this first, okay? Because we have cot to the power 4a in the front, isn't it? This can be written later also, but I am writing in the order itself, okay? So cot square a whole square means 2 2s are 4, cot to the power 4a, isn't it? Cot to the power 4a. Cot square a whole square means cot to the power 4a plus 2 cot square a minus cot square a. This is plus and this is minus. So we have to subtract this cot square a from 2 cot square a. So we have plus cot square a, because sign of greater number comes, the greater number is 2, so plus comes here. So this gives us right hand side, isn't it? Cot to the power 4a plus cot square a is the right hand side, equals to right hand side, hence proved. I hope we got this. Now let's move on to the next question, okay? Question number 8. Okay, now let's do question number 8. In the left hand side, we have sec a 1 minus sin a into sec a plus tan a. So we are going to use this, and this equals to 1. We are asked to prove this equals to 1. So let's begin. Left hand side equals to sec A 1 minus sin A, isn't it, whole sec A plus tan A. This is in the left hand side. We are going to use this and prove equals to 1, isn't it? Prove this equals to 1. So sec A we copy as it is, 1 minus sin A, this also we copy as it is, this sec A we copy as it is, okay, plus this tan A, now we convert this into sin A upon cos A form, okay. Tan A means sin A upon cos A, isn't it? Since tan theta, in the previous video I give you the formula, tan theta equals to sin theta upon cos theta, isn't it? This was the formula which I gave you in the previous video. So tan theta equals to sin theta upon cos theta, that means tan A equals to sin A upon cos A. Or sec A we copy as it is, 1 minus sin A we copy as it is, okay. This sec A we copy as it is, plus this sin A we copy as it is. Now this cos A, if you take to the numerator, it becomes sec A. Are you getting me? So sin A into sec A is actually tan A. Sec A means, cos theta means 1 upon sec theta. This was the formula which I gave you in the previous video, isn't it? Cos theta equals to 1 upon sec theta, and sec theta equals to 1 upon cos theta. They are just the reciprocal of each other. So cos A is in the denominator, so if you take this cos A to the numerator, it becomes sec A, okay. So we have sec A and sec A here. Let's take this sec A common out, okay. So we already have one sec A here, and another sec A comes from this two, so this becomes sec square A, because sec A was already here. Now another sec A comes from this, isn't it? That sec A and this sec A becomes sec square A. Now within the bracket remains 1 minus sin A, and this sec A is taken common out, so 1 remains here, plus this sec A is taken out, so sin A remains here. Are you getting me? Very, very simple, isn't it? So this sec square A, so this is, let's assume this one as A and sin A as B, okay. A minus B, A plus B, isn't it? So we know the formula, A minus B into A plus B equals to A square minus B square, isn't it? So A minus B into A plus B can be written as A square minus B square, isn't it? A square means 1 square, 1 square means 1, minus B square means sin square A, B sin A. So this sec square A we copy as it is, okay. Now this 1 means, since we know that sin square theta plus cos square theta equals to 1, so this 1 can be written as sin square A plus cos square A, isn't it? So 1 is written as sin square A plus cos square A. Sin square A plus cos square A gives us 1. This minus sin square A we write as it is, okay, minus sin square A. Now this minus sin square A and this plus sin square A, they cancels out each other, isn't it? So we have sec square A into cos square A, because these two are gone. So sec square A into cos square A, isn't it? Plus cos square A can be written as 1 upon sec square A, because cos theta equals to 1 upon sec theta. So this cos square A can be written as 1 upon sec square A. So this sec square A and sec square A cancels out, so we have 1. This one is the right hand side, RHS. Hence proved, okay. I hope you got this. Now let's move on to the next question, that is question number 9. Okay, now let's do question number 9. This question is similar to the previous question, question number 8, okay. Let's do this also. We are asked to prove this expression equals to 1, okay. So in the left hand side we have cosec A whole 1 plus cos A, cosec A minus cot A, isn't it? So using this, we are asked to prove this equals to 1. Okay, now let's copy this everything as it is. Okay, this is cosec A, 1 plus cos A, and this is cosec A minus this cot A can be written as cos A upon sin A, isn't it? Since cot theta is equal to cot theta equals to cos theta upon sin theta. Okay, tan theta equals to sin theta upon cos theta, and cot theta equals to cos theta upon sin theta, just the opposite. So cot A can be written as this cot theta can be written as cos theta upon sin theta. So cot A can be written as cos A upon sin A. So upon sin A, if you bring that sin A to the numerator, it becomes cosec A, isn't it? This sin theta, when you bring to the numerator, becomes cosec A. So cosec theta means cosec A. Are you getting me? This sin theta equals to 1 upon cosec theta, isn't it? Sin theta and cosec theta are reciprocal of each other. So cosec theta equals to 1 upon sin theta. Are you getting me? Sin theta equals to 1 upon cosec theta, and cosec theta equals to 1 upon sin theta. If you bring the sin theta to the numerator, it becomes cosec theta. So cot A means cos A upon sin A. So cos A upon this cos A upon sin A. That sin A, if you bring to the numerator, it becomes cosec A. So now let's take the cosec A common from this two. Okay, cosec and cosec A is taken common out, and we already have one cosec A here. So this cosec A and that cosec A becomes cosec square A, isn't it? Cosec square A. So 1 plus cos A, 1 plus cos A. Here we have taken this cosec A out, so we have only 1 minus this cosec A is out, so we have cos A in the bracket, isn't it? In the bracket. So now we have 1 plus cos A, 1 minus cos A. Let's assume that 1 as A and cos A as B. Okay, so we know that A plus B, A minus B means A square minus B square, isn't it? So cosec square A we copy as it is. Now this A plus B and A minus B can be written as A square minus B square, isn't it? Sorry, this is cos, isn't it? Cos square A. A square means 1 square, 1 square is 1, minus B square means cos square A. So this cosec square A we copy as it is, cosec square A. Now this 1 can be written as sin square A plus cos square A, isn't it? 1 is sin square A plus cos square A. Oh, this is square. 1 means sin square A plus cos square A. This minus comes here, and cos square A is cos square A, isn't it? We copy this cos square A as it is. So this plus cos square A and this minus cos square A can be cancelled. So we have cosec square A into sin square A, because these two are cancelled. So we have cosec square A into sin square A. So cosec square A into, if we take the sin square A to the denominator, it becomes 1 upon cosec square A, isn't it? Cosec theta equals to 1 upon sin theta, and sin theta equals to 1 upon cosec theta. This sin theta is in the numerator. If you take to the denominator, it becomes cosec theta, isn't it? So we have sin square A in the numerator. If we take this sin square A to the denominator, it becomes cosec square A. I hope you are getting me. Now let's cancel this cosec square A and cosec square A. So we have 1. 1 equals to right hand side, isn't it? Hence proved. I hope you got this. Now let's move on to the next question. That is question number 10. Okay. Okay, now let's do the next question. That is question number 10. Okay. In the left hand side we have sec square A plus cosec square A, and we are asked to prove this equals to, in the right hand side we have sec square A into cosec square A. So let's begin. In the left hand side we have sec square A plus cosec square A, isn't it? We have this in the left hand side and we are asked to prove this equals to this. So this sec square A can be written as 1 upon cos square A, isn't it? Since we know that sec theta equals to 1 upon cos theta and cos theta equals to 1 upon sec theta, and cosec theta equals to 1 upon sin theta, isn't it? Cosec theta equals to 1 upon sin theta. And tan theta, let me write this. This is not used right now, but even then I am writing this for you right now, okay? Tan theta equals to 1 upon cot theta. These are the opposite. Tan theta is opposite to cot theta, sec theta is opposite to cos theta, cosec theta is opposite to sin theta. Because sin theta equals to perpendicular upon hypotenuse and cosec theta equals to hypotenuse upon perpendicular, isn't it? We know this, so this is why this relation comes. They are just the reciprocal of each other. So this sec square A can be written as 1 upon cos square A plus cosec square A can be written as 1 upon sin square A, because cosec theta equals to 1 upon sin theta, so cosec square A equals to 1 upon sin square A. Okay. Now let us take the LCM of the denominators. We have cos square A into sin square A. So the LCM of cos square A into sin square A is cos square A dot sin square A. Dot means into, okay? Cos square A into sin square A. Cos square A times sin square A. Okay, this is the LCM between these two. So cos square A into sin square A is this. So this sin square A into 1 is sin square A plus sin square A into cos square A is this. So cos square A into 1 is cos square A, isn't it? Cos square A into 1 is cos square A and sin square A into 1 is sin square A. So we have sin square A plus cos square A in the numerator. So we know the formula: sin square theta plus cos square theta equals to 1, isn't it? Sin square theta plus cos square theta equals to 1. That means sin square A plus cos square A equals to 1. So in the denominator we have cos square A into sin square A. Are you getting me? I hope so. So now let us take this cos square A to the numerator. It becomes sec square A, isn't it? Because they are the reciprocal of each other. So cos square A, if you take to the numerator, it becomes sec square A. And this sin square A, if you take to the numerator, it becomes cosec square A, isn't it? Cosec square A. This is into. Dot means into. Okay. So in the right hand side, we have sec square A into cosec square A. So this is sec square A into cosec square A equals to right hand side. Hence proved. So I hope you got this. Thank you so much for watching this video. We will continue the chapter in the upcoming video, okay, from question number 11 onward.